let's talk about the X-bar chart. We use the X-bar chart to monitor the average of a process. We have two key questions in mind. How can we construct a chart? How can we use the chart to decide whether the process is in control or not? Let's take an example. A fire department is concerned with its ambulance response times measured in minutes. The target average response time is 15 minutes. Each week, a sample of 3 observations is collected. Data from 5 samples were collected when we believe the process is in control. So when we say the process is in control, what do we mean? That means nothing is wrong with the fire department and everything is working fine. In that case, we collected the following samples, and for each sample, we collected 3 observations. So in the first week, we collected 3 response times, 15.8, 14.9, and 15.5. So does that mean there were only 3 incidences of people calling for an ambulance this week? No, there were more than 3 instances. We just collected 3 of them. And we repeat this every week. In the next week, we collect 3 response times. That's sample number 2. Now to monitor this, which chart should you use? The response times can be measured in decimals, so you can use the X-bar chart or the R chart. And since we want to monitor the average of the process, we can use the X-bar chart. So in the X-bar chart, the X-axis is every week number 1, 2, 3, etc. The Y-axis is the sample mean. And we have the upper control limit and the lower control limit. And we can compute these from our data set. So to compute them, we're going to use these formulas. The upper control limit is X double bar plus A2 times R bar. The lower control limit is X double bar minus A2 times R bar. So how can we compute these numbers? X double bar, A2, and R bar. First, we need to compute the sample mean of each sample, and that's the average of all the observations within a sample. So for the first sample, we have 3 numbers, so average them, add them up, divided by 3, 15.4, that's the sample mean of the first sample. And we repeat this for the rest of the samples. The sample number 2, compute the average of these, that's the sample mean of the second sample. So we repeat this, and then we compute the average of all the sample means, that's X double bar. So add them up and divide it by 5, we get 15.2. Next, how can we compute R bar? First, we need to compute the sample range, R. That's the largest value minus the smallest value within a sample. So for the first sample, what's the largest value within a sample? 15.8. What's the smallest value? 14.9. The difference is 0.9. We repeat this for the rest of the samples. Take the second sample, take the largest value, and minus the smallest value. That's 0.9. And we repeat this. And then we compute the average of all R values, that's R bar. So add them up, divided by 5, 2.46, so that's R bar. So we found X double bar, we found R bar, then how can you find A2? We can find it from the following chart. In the first column, we have the size of the sample N, which is the number of observations taken in each sample. And in the next column, we have the factor for upper control limit and the lower control limit for the X-bar chart, which is A2. So A2 depends on the size of the sample. So what's the size of the sample in our example? Is it 5 because we collected 5 samples, or is it 3 because we collected 3 observations for each sample? It's 3 because the sample size is the number of observations within a sample. So n equals 3. So for 3, A2 equals 1.023. So we can plug it into the formula. A2 is 1.023. Then the upper control limit is 17.7, and the lower control limit is 12.7. So now we are ready to construct the X-bar chart. The x-axis is the sample number or week. The y-axis is the sample mean. The upper control limit is 17.7. The lower control limit is 12.7. And the center line is x double bar 15.2. Let's move on to part B. The fire department kept collecting samples as follows. Is the process in control according to the X-bar chart? We already have the X-bar chart from the previous part, and we want to use this to decide whether the process is in control or not. We want to use the following 3 samples. Sample number 6, 16.8, 17.2, and 19.2. So let's plot this on the X-bar chart. Sample number 6, should it plot all 3 values, 16.8, 18.2, and 19.2 for sample number 6? No, remember, the y-axis of the X-bar chart is the sample mean, so we need to find the sample mean for each sample. So we have to compute the sample mean of these, compute the average of these 3, that's 18.1. Also, for sample number 7, compute the average of these, 16.1, and then compute the average of these, 16.1, and we can plot this on the X-bar chart. So for sample number 6, the sample mean is 18.1, which is above the upper control limit. For sample number 7, the sample mean is 16.1, which is below the upper control limit. And then for number 8, it's 16.1. Now we can make a conclusion. Is this process in control? Now, if one or more of the sample means are outside the control limits, we conclude the process is out of control. And since we have one sample mean that's outside the limit, we conclude that the process is out of control.